Can you hear me?
Yes, sir.
While I was taking the last class, we got disconnected. Can you remember? Can you remember the topic after which we got disconnected? This
The
was
his-
the overview of the course. This was said.
yes, sir. The
Sir,
history of machine learning. Yes, sir. This slide.
so this
Yes,
slide was completed.
this slide was completed, and this one.
No.
No, sir.
Okay. Okay. Let me start from this slide. Okay, so that we can correlate the topics with other slides. Okay. Okay, let us take a quick review of machine learning history. So, in the year 1950, Alan Turing created a test called Turing test, through which he tries to determine if a computer has real intelligence or not. To pass the test, a computer must be able to fool a human into believing it is also human. So, what was the test which was done by Alan Turing? So, in the test, Alan Turing uh, place one computer on machine in a room, and other room will be occupied by a human. Okay. Now, another human or another person was standing outside both the rooms, but he cannot see either the machine or the human, which uh, uh, which is kept in the another room. Okay. Now, the person who is standing outside both the rooms will try to get engaged in conversation with uh, both the machines and the human being. Okay. Now, if the person does not understand to whom he is talking with, so that means the machines can imitate the human behavior or the act, or you can imitate the machine can imitate the cognitive process of the human, so that the machine can fool the human into believing it is also human. Okay. So this was the Turing test, which was proposed by Alan Turing in the year 1950. Okay. In the year 1952, Arthur Samuel first wrote the computer learning program. The program was the game of checkers. Okay, so this was the first learning program which was written by Arthur Samuel in the year 1952. In the year 1957, Frank Rosenblatt designed the first neural network for computers, which is called the perceptron, and that simulate the thought process of the human brain. Okay, so this was the first neural network program which was written in the year 1957 by Frank Rosenblatt. Okay, in the year 1967, the nearest neighbor algorithm was written, which was allowed the computers to begin using very basic pattern recognition. So this nearest neighbor algorithm was used when it was written. So it was used to recognize the basic patterns with different objects. Okay, and this could also be used to map a route for traveling salesmen starting at random city, but it ensures that they visit all the cities during a short tour. Okay. In the year 1979, students at Stanford University invent the Stanford card. so which can navigate obstacles in a room on its own. So when they designed that Stanford card, so to to test the whether to test whether the Stanford card, which was designed by the students, can navigate the obstacles successfully, which are placed in a room on its own or not. Okay. In the year 1981, Gerald De Jong introduced the concept of explanation-based learning. Okay, so if we talk about the formal introduction of machine learning theory, then we can consider 1981. Okay, so in 1981, Gerald De Jong introduced the concept of explanation-based learning, in which a computer analyzes training data and creates a general rule, so that can follow by discarding unimportant data. Okay. In the year 1985, so Terry Sejonsky invents NetTalk, which learns to pronounce words the same way a baby does. Okay, so this was the tool which was invented in 1985. In 1990s, work on machine learning shifts from knowledge-driven approach to data-driven approach. So if we talk about the big data concept, so 1990s are considered to be the years in which the big data concept was introduced. Okay, so machine learning basically shifted from knowledge driven approach to data driven approach in the year 1990s. Okay, in the year 1997, IBM's Deep Blue beats the world champion at chess. So you can remember, or if you know the story of the IBM's Deep
Yes,
Blue,
sir.
yes, yes, which beats the world champion at chess. In the year 2006, uh, Jeffrey Hinton coins the term deep learning to explain new algorithms so that let computers see and distinguish objects and text in images and videos. So basically, if we talk about the deep learning, introduction of deep learning theory, so previously it was introduced in different way, but what Jeffrey Hinton does that he first designed such a neural network, okay, so which is called deep learning, and these deep learning algorithms are able to explain how computers see or can distinguish the objects and text in images and videos. Okay. In the year 2010, the Microsoft Kinect was introduced, which can track 20 human features at a rate of 30 times per second. So, to capture the movement and gestures of humans, so Microsoft developed the Microsoft Kinect. Okay, so this is the tool by which someone can take the movement and gesture features at the rate of 30 times per second. In the year 2011, IBM's Watson beats its human competitors at Jeopardy game. In 2011, Google Brain was developed, and it uses the deep neural network, which can learn to discover and categorize objects much better way a cat does. Okay, so if we consider to animal which can distinguish the objects in the way to in the way a machine does, then Google brain was developed using the same concept using deep neural network. Okay. In the year 2012, Google's XLab develops a machine learning algorithm that can able to autonomously browse YouTube videos uh, to identify the videos that contain cats. Okay, so this was developed by Google in the year 2012. In the year 2014, Facebook developed DeepFace. Okay, so What is the deepface? So deepface is a software algorithm that can able to recognize or verify individuals on photos to the same level as humans can. Okay, so deepface is able to recognize the individuals or the persons based on the photos at the same level as humans can. Okay, so same level of cognitive process was instilled or developed by the Facebook, which is called deepface. In the year 2015, Amazon launches its own machine learning platform. You can you some of you may know that AWS was that platform based on machine learning. Okay, machine learning algorithms. In the year 2015, Microsoft creates the distributed machine learning toolkit. Okay, in the year 2016, Google's artificial intelligence algorithm beats a professional player at the Chinese board game Go. Okay, so this was considered the world's most complex board game and many times harder than chess. So this is the history of uh, machine learning theory or machine learning algorithms. So now formally we are going to introduce the machine learning. So when you talk about the machine intelligence or talk about the machine vision, then questions come around our mind that whether a machine can see like humans, whether a machine can understand the facts like human, whether machine can imitate the cognitive process of humans, or whether the machines can act or behave like humans. Okay. Now to summarize those, summarize those thoughts or summarize those facts which are understood by humans. The Arthur Samuel defined the term machine learning. Okay, so according to Arthur Samuel, machine learning algorithms enable the computers to learn from data and even improve themselves without being explicitly programmed. Okay, so this was the definition which was coined by Arthur Samuel. Okay. Now let us consider there is a computer program. So and this computer program is able to learn from experience. Okay, and whenever the computer program is learn from experience E with some with respect to some class of task T, okay, and performance measure P, then we may conclude that the computer program can able to improve its performance at doing the task T as measured by P and provided the experience E. Okay. Now, here the experience is nothing but the data set which has been provided to the computer program so that the computer program can learn from the experience E. Okay, or learn from the data set E. Now, if we decide about some class of tasks or a task key, and if we measure the performance with P, then we believe that the computer program can learn from the experience or the data set which has been provided to the computer program with respect to some class of task T, and uh, gradually when the computer will learn, the computer program will improve the performance at doing the task T. Okay, so in different way we can articulate this fact. However, according to Arthur Samuel, the definition of machine learning can be better understood by these entities. Okay, experience C, task T, and performance measure P. Now, to understand the machine learning process in better way, we can consider two examples. One is the checkers learning problem and handwritten recognition learning problem. Okay, or a handwriting recognition learning problem. So in the checkers learning problem, so we can consider a task T, okay, performance measure P. So either the performance measure is the percentage of games that own against opponents, okay, and here the training experience E is referred by playing practice games against itself, okay. So this was considered as experience E. So based on these facts, or based on these entities, the checkers learning problem or checkers learning algorithm can learn from the training experience. So which is nothing but the playing practice games again itself, and it can improve the performance. It can improve the performance by winning the games against opponents. Okay. So here the task is the playing checkers.
Sir,
So
hello.
yes,
Sir, playing practice game against itself means it will play the game on its own.
no, no. So that is why the artificial intelligence or machine intelligence come to that point. Okay. So if we talk about the machine intelligence, then the machines can uh, uh, able to understand or analyze the facts by itself. Okay. So if the machine is able to or if we consider the checkers learning algorithm is able to playing the practice games again itself, then we can conclude that here the learning algorithm or the checkers learning algorithm is able to imitate the human behavior. Okay, so if the checkers in the checkers learning problem, if the checkers learning algorithm is playing against a human being, then the same way the checkers learning algorithm can play with itself, okay, against itself. So that is why
Okay, sir.
this learning problem is important to understand the process of learning in machines. Okay.
Sir, may I ask one question?
Yes, yes, you can ask.
Sir, when suppose I have built a machine learning which program which can actually play chess on its own. So, sir, when it is playing the practicing the game against itself, then sir, initially it doesn't have any experience. So, sir, it will give some random moves. Uh, Sir, then how can we reach to a point when the machine almost become an expert in chess?
Yeah,
Something.
for that particular problem, the reinforcement learning reinforcement learning was introduced. So we will come to that point. We will come to that point how reinforcement learning can be used to distinguish between two different situations or two different facts. So in that case, the what machine learning algorithm will do? Machine learning algorithm will consider the situation by which the machine learning algorithm can learn something. Okay,
Okay, sir.
and machine learning algorithm at the same time, machine learning algorithm will discard the situations or discard the facts, so by which the machine learning algorithm not going to learn anything. Okay, or it will be learn something which is not considered for further in the set of experience. Okay, so we will provide the data in such a way that machine learning can learn and improve its performance gradually. Okay, so here the training experience is refers to a data set. Okay, so we will provide the data set such a way that machine learning can able to learn from the experience or from the given data set, so that the machine learning algorithm can improve its performance gradually. Okay,
Okay, sir.
so we humans will provide such data. After that, after certain point of time, so we will stop providing the data, Now the machine learning algorithm will be able to learn from the experience. Able the experience means the provided data.
So that means the chess engine that the deep blue that beaten the world champion. So before beating the world champion, the engine already has the data set played by the world
Yes,
champion.
yes,
I guess.
train data set was provided. That means the machine learn deep blue itself is a train model. Okay, train model.
Yes, sir. Yes, sir.
Okay, so once it is trained, then machine learning algorithm, any machine learning algorithm will able to learn from that trained data. Okay, if we
Okay,
provide
sir. Okay, sir.
okay, if we provide a new data every time, then what machine learning algorithm will do? Machine learning algorithm will learn from that new data every time, and it is going to include that new experience in the trained model, in the trained data set. Every time when we provide some new data, okay, new data or present a new data to the machine learning algorithm, so machine learning algorithm will be able to learn something from that new data, and it will be included in the training data set. So that is why we are saying that machine learning algorithms learn from training experience. Okay.
Yes, sir.
Now we will consider handwriting recognition learning problem. So in handwriting recognition learning problem, what will be the task? So tasks will be to recognize and classify the handwritten words within images. So this is the task. Okay. So we call this task T. So what would be the performance measure P? Here the performance measure P would be the percent of words that are correctly classified. Okay. So this would be the performance measure P. So what would be the training experience? So training experience E refers to a data set of handwritten words with given classification techniques or given classification, what we say the given classification algorithm. Okay, so if we provide such database of handwritten words, so this will be called the training experience C. So if we provide these three entities to a handwritten recognition algorithms, and what that algorithm will do, algorithm will perform the task T provided some training experience C, and gradually it will increase the performance P. Okay. Now if I consider situations where we can apply the machine learning algorithms, so there are some situations, or there are some we what we call the uh, regular tasks that humans do. So in such situations the machine learning algorithms will be needed. Okay, so if I consider to navigate on Mars, then in such situation human expertise does not work. Okay, so in that situation machine learning algorithm can be used in place of human expertise and do the same work or same tasks in such situations. Okay, so one of such situation is navigating on Mars. Okay, now if I consider that humans are unable to explain their expertise in some situations or in some tasks like speech recognition, then we can use the machine learning algorithms in place of humans to understand understand the various aspects of speech recognition. Okay, so in this situation also we can use machine learning algorithm. Okay, now if I consider a situation like stock market, so stock predicting in the stock market or routing on a computer network, so here what we see that solutions frequently change. Okay, solutions are frequently change in stock markets as well as in routing on a computer network. So in such situations we cannot use the human expertise. Okay, so in such situation if I use the machine learning algorithms to predict better way, okay, or grasp the changes which are being done during that time or during that situation, then better to use the machine learning algorithms or some artificial intelligence tools. Okay. Now, sometimes we need the solutions which are to be adapted to a particular cases, like user biometrics. Okay, so what biometric system does? The biometric system recognize the persons by biological evidences which are found on human body. Okay, so like face image, like ear image, like fingerprint image, like iris image. So through these biological evidences which are found on human body, uh, can uh, can be used in the machine learning algorithm to recognize the persons. Okay. Now here what we see that when we provide some solutions like classifying the individuals based on some biological traits, then we will see that the algorithms need to be adapted to a particular cases. Particular cases means if the algorithm is trained for recognizing the persons in a control environment, then how that algorithm will able to understand about the uncontrolled environment, okay, or degraded environment. That means the algorithm needs to be adapted. Okay, that means the algorithm need to learn about the uncontrolled environment, about learn and that algorithm also needs to learn about the degraded environment, uh, so that the individuals which are presented in the degraded environment or uncontrolled environment can be recognized by the same machine learning algorithm for person identification. Okay, so these are the four broad areas where machine learning algorithms can replace the human expertise. Now, what are the different applications of machine learning algorithms? So if we consider the application areas of machine learning, then we can see that machine learning application of machine learning areas are vast. Okay, or they are heavily used in almost in every fields like healthcare, retail, manufacturing, banking and finance, transportation. Okay. Now, if we consider such machine learning systems or machine learning algorithms, then Netflix, one such system is recommender system. Now, what is recommender system? So Netflix first designed such a recommendation engine or recommender system, so which is made up of algorithms and that can filter the content which are based on each individual user profile. Okay, and this engines is able to filter over 3000 titles at a time using 1300 recommendation clusters which are based on user preferences. Okay, so based on the user preference or based on the user profile, so Netflix recommendation engine is able to filter the content almost about 300 titles at a time. Okay.
Sir,
Yes.
sir, sir, when the user does not have any search history, then sir, how they recommend?
If the user does not have any user preference, then the recommendation engine will see the user profile. Okay, based on the user profile, he will the engine will filter the content. If you
Okay,
have
sir.
some profile in Facebook, Twitter, okay, and LinkedIn, so based on those profile, or if you have profile in their recommendation system, okay, so based on that profile or based on the profiles in the other social networking sites, so Netflix recommendation engine will filter the content. So as per your preferences, as per your choice, as per your user profile, so recommendation system does this filtering.
Okay, sir.
Sir, what is sir NLP is used here or what is used
No,
in?
no, there is here reinforcement learning is used.
Okay, sir.
Reinforcement learning. I will come to that point. Okay.
Okay, sir.
Now, what are the different areas in healthcare which are which are used machine learning algorithms? So here, what machine learning algorithm does, that uh, machine learning algorithm provides a self-learning neural network environment. What is self-learning neural network environment? So here, the self-learning neural network environment is able to increase the quality of treatment by analyzing the external data. So basically, what this algorithm does, so these algorithms analyze the external data on patient condition, on X-rays, on CT scans, on various tests and their screenings. Okay, so these are the various uh, source of data sets on which the self-learning neural network algorithms analyze this data, and based on the data, the quality of treatment can be improved. Okay, so what are the different areas that we can consider for can consider for machine learning algorithms? So here are disease identifications and diagnosis. Okay, medical imaging, drug discovery and manufacturing, personalized medical treatment, smart health records, and also some specialized area like disease prediction. Okay, so in disease prediction also the machine learning algorithms are widely used.
Sir,
Yes.
sir, if the machine can detect the disease and also recommend the medicines based on the symptoms of one
No,
patient.
machine learning algorithms do not recommend medicine. Okay,
Oh, sir.
so only what machine learning algorithm does, that machine learning algorithm can predict the disease. Okay, now,
Okay, sir.
what doctors do, that doctors, according to the doctor's diagnosis, okay, so they understand something about the disease. Now, if at the same time the uh, machine learning algorithms predict the disease in some different way. Okay, so now both these predictions will be tally. Okay, both these prediction will tally together and see if the doctors, so what they understood about the disease are found to be correct or not. Okay, so
Sir,
they can tally their understanding about the disease with the machine learning algorithms.
says if it goes in this way, then one day it may come that there is we don't need the doctor, a machine is sufficient for our treatment.
Yeah, that day is coming. We don't know, but in some way, the healthcare sectors will be sufficient to have that kind of environment. Okay, so I think most of you are familiar with the new terms that are being used around social media, like metaverse. Have you heard this word, metaverse? So metaverse will have that kind of facility or that kind of environment. So that environment will be provided to the users. So users can understand different aspects or different entities in better way using metaverse. So metaverse will provide that kind of environment. Okay, in that environment, different many different entities will be integrated together. Now, what are the different applications of banking and finance? If we consider the applications of machine learning algorithms in banking and finance, then machine learning algorithm basically used to detect fraud, automate trading activities, and provide financial advisory services to the investors. Okay, so these are the different areas in banking and finance where machine learning algorithms can be used. So, financial monitoring, making investment predictions, process automation, secure transactions, and there are many such areas where machine learning algorithms can be used. Now, if we consider the manufacturing industry, so in manufacturing industry, machine learning algorithms are heavily used. Okay, so initially, what we have done, we have we have divided the manufacturing, we have divided the using of machine learning algorithms in four different areas. One is the monitor and predict failure, okay, improve production, augment production design, and automate operations. So these are the four broad areas in manufacturing industry where machine learning algorithms are heavily used. Okay. And the next application, if we consider the transportation, then in transportation, machine learning algorithms are used in car navigation systems, traffic signal control systems, container management systems, variable road signs, automatic license plate recognition, speed cameras, CCTV systems, accident detection systems, weather information systems. So these are the major areas in transportation where machine learning algorithms are used successfully. Now, if we consider the next most interesting area of machine learning algorithms, then obviously the predictive analytics. So the predictive analytics is considered to be the most interesting area for machine learning algorithms. So in this predictive analytics, so we can model the statistical facts, or we can design the consumer behavior model. We can design the scoring model. We can design the visualization model. Uh, we can design the decision making model. Okay, so these are the different areas of predictive analytics, so where we can apply the machine learning algorithms. Okay, so these are the different machine learning tools which you can use to develop an useful machine learning algorithm. Okay, so these are the different machine learning tools like Python, Keras, AWS, so Kafka. So these are the PyTorch. These are the different machine learning tools, so which are available freely. So you can use these machine learning tools and can develop an useful application. Okay, so now we will see the types of machine learning algorithms. So what are the different types of machine learning algorithms that we can deal with? So there are five different types of machine learning algorithms. Okay, association based learning, supervised learning, unsupervised learning, semi supervised learning, and reinforcement learning. Okay, now if we talk about the association based learning, then this association based learning is considered to be the rule based machine learning algorithm. Okay, rule based machine learning algorithm and data mining technique, so that can be used to find the important relations between variables or features in a data set. Okay, so we will take an example and we will see how the association learning works in the applications which are used by human beings. Okay, so what is supervised learning? So supervised learning, if we consider the supervised learning algorithms, then supervised learning algorithm is considered to be the most basic types of machine learning algorithm, in which the machine learning algorithm is trained on level data. Okay, so uh, when we consider the supervised machine learning algorithm, so machine learning algorithm and based on the supervised learning strategy, we can create a model, okay, trained model, and this trained model is based on the label data. That means we know about the class of the data, and not only we are considering the data, but as well as their data level, okay, as well as their levels, okay, corresponding levels we are
Sir, what
considering.
are the classes of the data?
We will come to that point, don't worry. Suppose we are okay, so let us consider an example of supervised learning. So if we consider to develop an machine learning algorithm which can successfully classify the person based on their faces. Okay, so what we will do in that case, we will take the photo of that person. Okay, we will take an image of that person, of face image of that person, and we will extract some features. Okay, Now the when the features when we extract the features and encode the features into a feature set, that feature set will be used for classification. Okay, now not only the features, we will also add the corresponding class label. That means the some kind of identification about that person. Okay, that means if the person if we deal with the identification system, okay, human identification system, then what will be the class level? If we add the class level with some face image, so what will be the class level?
So skin color.
No.
Face.
Yeah, face itself is a data.
So human detected can be
Yeah,
one class.
how if I
Say
train a
retina. Say retina.
no, retina is another evidence like face image. Through face image, we are trying to classify the persons. Okay.
Say what?
Man and woman.
No, that is the broad classification. Man and woman are broad classification. So how you will be identified by a machine? Even myself will be identified by a machine. Okay,
Say it
you
is
all will be identified by the machine. How you will be identified by the machine? The face data is not sufficient. We need to label that data also. So how we can assign the levels, class levels basically. We are talking about the class levels.
So
So,
person.
so here we can what we can do, we can assign some class label. Okay. So with respect to myself, with respect to you, what we will do, we can introduce some numerical identification. Okay, numerical identification. So if I talk about some identification like C100, so C101, C102, C103, so these identification numbers, alphanumeric identification mark or label will refer to some individuals. Am I correct? So they
Yes,
will
sir.
refer
Yes,
to
sir.
some individuals. Now, if I able to assign these levels to our training data set and we run, then we execute the supervised learning algorithm on this data, then what supervised algorithm will do? This supervised algorithm will learn something about the data with the associated levels, and accordingly the supervised learning algorithm will act. So we have trained the supervised learning algorithm for classification the individuals based on face image. Now only face image will not work, so we have to provide the levels to that face images. Okay, the levels means some kind of class information, so class information about individuals. Okay, so this is basically the task of supervised learning algorithm. So supervised learning algorithm is trained on the level data. Okay, and
Sir,
then
sir, who is doing the leveling?
hmm?
Sir, who is?
obviously the human beings
Okay, sir.
who are developing the supervised algorithm. Okay, if you are developing the supervised algorithm, who will provide the data? Obviously, you will provide the data, but after certain point of time, supervised algorithm will do not need any kind of experience or any kind of external data. Okay, that means that supervised learning will become an AI system. AI system, artificial intelligence system. So whenever it reaches to artificial intelligence system or machine intelligence level, then automatically the supervised learning algorithm can distinguish two different persons or two different individuals based on the face image. So at that time, we do not need to provide more data in the training data set. Understood?
Okay, sir.
Okay. So next learning algorithm may be unsupervised learning algorithm. So what is unsupervised learning algorithms? So unsupervised learning algorithms do not use labels. That means do not use labeled data. Okay. Now, if we train, if we execute the unsupervised learning application on some machine, then unsupervised learning algorithm can able to discover the structure of the data. Okay. So structure of the data means they are going to grouping the similar items to form a clusters. Okay, or reducing the data to a small number of important dimensions. So these two are the prime tasks which are done by unsupervised learning algorithms, making clusters and reducing the data to a small number of important dimensions. That means for dimensionality reduction, for making clusters, we can use the unsupervised learning algorithm. Now here, uh, you may surprised to know that this unsupervised algorithm can sometimes behave like classification algorithms. Okay, so classification algorithms without label data, because creating clusters means a kind of classification is done by unsupervised algorithm. Okay, so what we know about the supervised algorithm, that supervised algorithm can able to distinguish two different individual based on some biological evidence which are found on human body. Okay, that means for classification or prediction we can use supervised learning algorithm. But in case of unsupervised learning algorithm, unsupervised learning algorithm can be used for creating clusters and dimensionality reduction. Okay, so for both these tasks we can use unsupervised learning algorithm. Now, what is semi-supervised learning algorithm? So if we talk about the semi-supervised learning algorithm, then it basically combines a small amount of labeled data with a large amount of unlabeled data. So that is why this is semi-supervised learning. So such arrangement of labeled data with large amount of unlabeled data can be found in a deep learning algorithm like generative adversarial network. If we consider the generative adversarial network as a learning algorithm, then in this learning algorithm, we can provide the labeled data as well as unlabeled data. Okay, so in this way, the generative adversarial network may be considered as semi-supervised learning. Okay, or semi-supervised learning algorithm. So next learning algorithm, we can have reinforcement learning. Okay, now you can consider a situation where we can place a machine to distinguish between the water and the fire. That means if we present a glass of water or and a fire to the reinforcement learning algorithm which has been installed in some machine. Okay, that means both these items are provided or presented to that machine, and machine is able to learn from that entities, okay, or that data. Now what reinforcement learning algorithm will do in this case? One item is fire, another item is water. So in this situation, what that machine will do? Can you tell me?
Sir,
Hmm.
sir, it will try to predict the random outputs. So, uh, if it is correct, then it will
No,
stay.
no,
And
what
if,
what is what it has been correct? What is correct? What is correct? What is wrong? Yeah.
sir, if it is, sir, if two inputs are given, sir, water and fire, then it may predict the fire as water.
Basically, here reinforcement learning algorithms are trained in such a way that when reinforcement learning algorithm or the machines on which the reinforcement learning algorithm is running touches the water, that means we will encourage the machine to have such experience. But when the machine touches the fire, so we are not going to encourage that kind of activity which are been done by reinforcement learning algorithm. Okay, so that's to be very clear about the tasks that we are expecting from a reinforcement learning based machines. Okay, that means for the favorable outputs we will encourage or we will reinforce the machines, but for non-favorable outputs we are obviously going to discourage or punish. Okay, that means if the machine touches the water, we will we will say this is the favorable outputs which are being encouraged or reinforced, and when the machine touches the fire, then we will obviously going to discourage this task.
So that means, sir, in a game, when a particular method
Yeah,
wins,
by
then
this by this way of experiencing the items or experiencing the data by reinforcement learning algorithm, so obviously some learning will be done. So what is good or what is bad, if we can make such arrangement in front of or make such arrangement with the reinforcement learning algorithm, and uh, in that way we can teach the machines, we can teach or we can teach the reinforcement learning algorithm to learn from that experience or learn from such data. So one would be reinforced, another would be punished. Okay, that means for fire data, we will obviously going to not recommend for the reinforcement learning. Okay, in that case, we will discourage or we will punish. Okay, we will label that non-favorable task as punished or discouraged, and favorable task as encouraged and reinforced. Okay. So this way, reinforcement learning algorithm can learn about the data or learn about the environment in which the reinforcement learning algorithm is working. Okay. Any
Okay.
questions?
No, sir.
Okay. So in the next class, we will start talking about or we will be taking some examples. Okay. And we will try to understand how machine learning algorithms works. Okay. That's all for today.
Thank you, sir.